Testing, testing. Hey, people on the stream, just let us know in chat if this is too loud. All right, thank you for joining us tonight. We're going to get started here in a minute. This is Izen. Thanks.
Check, check, check. Oh, let me help with the volume. There's a bang the gong. Scott. Let's see. Oh, there he is. You ready? Okay. One more time. Okay. Where did he put the mallet? No. You want me to do it? All right. Can you hear me? Okay. Welcome, everybody. Welcome to the Berkeley Gateway Accelerator, to our very first MoonTech event. Yeah, that's what I'm talking about. Please find a seat. There's a couple seats right up front here, some seats in the back, some seats over here. Just want to say a couple words. Let's see, do I have a slide here? Yeah? Okay. My name's Matt Rappaport. I'm the director of the Berkeley Gateway Accelerator. We are a deep tech accelerator located right here in Berkeley, California. We are aiming to be the center of gravity of deep tech innovation and entrepreneurship here in Berkeley in the East Bay. So we run a lot of events. We invite a lot of people to our events, so you're always welcome to come. Follow us on luma.com/Berkeley Gateway Accelerator. This is our 14th event, I believe. We've done all kinds of events around robotics, around quantum, around space tech, around agricultural technology. So there's been quite a few, and we're always happy to host people here. If you have an event yourself that you'd like to do, or you have an idea for an event, please come see me, or Murray, or Kavisha, or Nirav, our team here. Thank you guys. Okay, so just quickly, our purpose here is to help accelerate deep tech innovations into the market. We are both running that with startups. We're also running programming for corporates and for government labs and other innovation groups. And we also are doing a summer academy that I'm very excited about, which we will do in June and July, 2 sessions. It's for high school kids and for college undergrads. So if you know anybody who's in high school that would like to learn about deep tech innovation, entrepreneurship, venture capital, please come see us. We're very excited about this program. And so, for this particular event, we have this incredible program that my colleague Scott, who I'm about to introduce you to, was instrumental in organizing and bringing together. He did this in collaboration with a couple other people, but I'm going to pass you to Scott Nisbet to give a quick introduction.
Thank you, Matt. And I just wanted to say how wonderful it is what Matt, Nirav, and the incredible Berkeley Gateway Accelerator team has created here for this event, but for the city of Berkeley, for the UC Berkeley ecosystem, for the whole Bay Area ecosystem. This event space is one, and this event is one example of what they've done. And it's going to continue. We have many more, and please keep track of the calendar. But what they've done is incredible. And what today's event is with Izen, who you'll meet here, who's moderating this. He is an incredible entrepreneur, organizer, and passionate about space tech and MoonTech. And this is an area that you're all going to hear more and more about. That name MoonTech may sound out there right now. It won't be. This is going to be an amazing race. You obviously hear the big names out there that launch rockets, that guy. He's going to throw a lot of money at this, but so is everyone else. And this is an amazing time to be paying attention and an amazing time to be alive here in the world, let alone here in the Bay Area. So with that, I'd like to introduce Izen, who will be moderating the wonderful panel we've assembled. And thank you again to Berkeley Gateway Accelerator and the team. So thank you.
Hi there, everyone. Welcome to tonight. I'm Izen Thornton, a founder of Lunar Autonomy Company. I've been working with BGA. They've been great people. They've hosted about a dozen events so far, and it's always great to work with them. I'd like to welcome up to the stage Jasmine, a member of a local Civil Air Patrol unit, to speak. So, Jasmine, you're part of Civil Air Patrol. Can you tell us a little bit about what that is?
Yes, so we are the United States Air Force Auxiliary, which means we're all volunteers. We're not enlisted or commissioned members of the United States military. And we have 3 missions. We have cadet programs, emergency services, and aerospace education. So for cadet programs, cadets, the members who are 12 to 21 years of age, they get hands-on experience with leadership and develop their character through character development classes. For emergency services, it's a little more self-explanatory. We find lost hikers and downed aircraft. And then for aerospace education, cadets get the opportunity to learn about the fundamentals of flight and cybersecurity and rockets in space. And cadets also get the opportunity to go up in the air with our flight of Cessnas. And they also get to do orientation flights, flight academies, which I've actually been to, or continue their flight training with the CAP pilot.
Excellent. I hear you're wanting to go into the Space Force. Tell me a little bit about your plans.
That's correct. So I'm looking to be a Space Force intelligence officer. I'll be joining ROTC in the fall here to make that dream happen, and I will one day get to space. That's the plan.
Excellent. Now, if there's one thing you need help with, one thing that the audience, maybe some members could help you with, what is that?
Yes, I would like help in my goal, getting to space through the Space Force preferably.
Excellent. Well, thank you, Jasmine. Contact information is on the screen, and she'll be here to speak with. Definitely worth a chat. Thank you. Could you take the chair? Next up, I want to introduce Raffaella Atti, a heliophysicist at NASA Langley, who is also CEO of HelioArc, which I'll talk a little bit about now.
Thank you very much for having me. So yeah, I'm Raffaella Atti. I work at NASA Goddard Space Flight Center. That's okay. And I'm the president of the board of the HelioArc Foundation. So we founded the HelioArc Foundation last year. And I was told that great founders are founders who are trying to solve a problem. So here's a problem we want to solve. It's space weather hazards on the moon. This is what I'm going to talk to you about today. Next. So first, some definitions. And I want to have a show of hands of who had never heard of the term space weather. You may have heard about the weather, but space weather. Okay. Okay, cool. So here's a definition from COSPAR. Space weather is applied research on the dynamic, highly variable conditions of the space environment, including the sun, its effects on society, and its extension within the solar system and on human biology. Heliophysics is the underlying science that can explain space weather. It's the study of the sun and its effect throughout the solar system. What you see there is the sun observed with Solar Dynamics Observatory, a NASA mission, and you probably heard about solar flares and these kind of things. These are the drivers of space weather. They are of solar origin. Next. Impact of space weather is underrated. Space weather has killed before. In the military, there's been a helicopter crash in Afghanistan due to disrupted communication that was revealed later by heliophysicists to be linked to what we call plasma bubble into the ionosphere. It blocked communications, and so hostile zone could not be really warned, and resulted into the crash of the helicopter. Next. Minor geomagnetic storm can create, can wreak havoc. And a very well-known space company lost an entire constellation of satellites to a space weather event, with an estimated loss between 50 million and 100 million. Next. Agrotech, precision agriculture and farming, they use GPS-based systems. There's been a massive geomagnetic storm called the Gannon storm that caused trouble to 39,000 precision farms. The estimated loss was about 1 billion. Finally, and that's why a lot of you are here, we have now a new race to the moon. And we want you to succeed in that. And this is our mission, to really make you aware, to raise awareness about the risks of weather so that you know what you're up against. There is something I want you to remember, and I will show you that in a video, is that on Earth we've been protected by a magnetic field, and the moon doesn't have that. That's where our problem begins. Next. So to understand space weather on the moon, it's important to understand space weather on Earth. Next slide. So this is an example of, on the right, observations of the sun in interplanetary space through what we call the coronagraph. The things that you see shooting off the sun, all the stuff that emanate from the sun, it's the solar wind. And you can see some of the effects of coronal mass ejection, and then the sort of snow that you see are hits of energetic particles on the imager, on the camera of this coronagraph. And on the left, it illustrates the damage it can do to electronics, which is, it can go from disruption of and a recoverable disruption of electronics to their entire destruction. Next. And so here is how we've been relatively well protected. So you see all the satellites there in different orbits around the Earth are within this magnetic shell, protective shell created by the magnetic field of the Earth that we call the magnetosphere. It's been an umbrella, a cosmic umbrella protecting us from the effects of solar radiation and particles of solar wind and the magnetic field of the sun transported by the solar wind. It's been our protector, and it still is. Next. Now, this is the mission actually I work on, and it's the PUNCH mission. It's a new mission that really shows you interplanetary solar wind. And you're going to see a flyby. If we can play the video maybe one more time. You're going to see something there passing. This is actually the moon, where you want to go. That moon is sunbathing. It is swimming in that solar wind without protection, without that umbrella. And this is why going to the moon is hard. It's one of the hazards that people are facing when you want to send something to the moon. No protection, unlike on Earth. Next. And so this very nice slide was created, and I was authorized to show it to you by the Moon to Mars Space Weather Analysis Office at NASA Goddard, with whom we collaborate. It illustrates the kind of things that you need to be aware of when you have electronics or people going around the moon. You have surface turbocharging, dust transport, radiation, meteorite impacts, coronal mass ejections from the sun, solar flares, of course, solar energetic particles, magnetotail interaction, and galactic cosmic rays, which are super energetic particles that can really damage your electronics and create things like single event upsets, which is something that Airbus has faced before. That's an entire other story that I'm happy to talk about during our networking. Next. So at the Foundation, we're a 501c3 profit. Our mission is really to be your first line of knowledge against space weather threats. Next. And please meet our board. Our vice president is also here. Shadi Salim is a very good space physicist at UC Berkeley at the Space Science Lab. And we have our other board directors that are highly specialized. They all combine lots of experience in either AI or space physics. Some of them have worked also at NASA Goddard like me. Others are still working with me at NASA Goddard. And we're really happy to assist you in your mission to the moon. Next. So basically, all these satellites have been around the Earth and near the sun to really collect a massive amount of data. And we've accumulated hands-on experience with those missions. We've accumulated a massive amount of human knowledge that cannot be really replicated by AI. And so our consortium of experts offers the scientific depth that you need to understand the risks of space weather. So please feel free to talk to us about this. Next. So you will know more on our mission, vision, and goals on our website. Feel free to reach out to me at any time. And so the take-home message today is that space is rough. There are lots of hazards that you may not know about. And so if you want to go fast, you know the saying, go alone. If you want to go far, let's go together. Thank you, everyone.
Thank you, Raphael. Yeah. I didn't really think about lunar weather or anything before, getting into space and that sort of thing. But that's really the #1 killer on the moon. You have, temperature, radiation, those sorts of things. So definitely appreciate you coming out. Now, as we prepare for our panelists, I'd like to let you know how we're going to do our Q&A today. It's going to be a little bit different. Using the live stream link that everyone was sent on Luma, you can go into the chat and ask your questions there. If your question is not answered during the panel, myself or one of the panelists will reach out to every single question and give you a response. So if you have a question, drop it in the chat. Okay, and then we'll wait just a minute while we get these chairs set up. Brandon's just clicking. Fourth chair. Can you run into the kitchen and grab a chair from there? Just give us 1 minute. We place the chair. He's got the chair. No worries. And then just grab me a water. All right, at this point, I'd like to invite our panelists up. If you could please enter stage and take your seats. Yes. Thanks. Yep. Okay, so just introducing our panelists. First, we have Terry, Chief Roboticist at NASA Ames. If you could speak a little bit about yourself.
Sure. Good evening, everybody. I've worked at NASA for, 22 years now. I've been at NASA Ames down in the South Bay that entire time, although my role at Ames is actually split. I'm currently working half-time on NASA's first lunar rover mission called Viper, which is scheduled to launch in August of next year. And then half of my time is spent working for NASA headquarters, which up until last Friday was called the Space Technology Mission Directorate, and you can kind of guess from the name what we do. NASA is now undergoing a realignment to help make sure that everything that can be basically focused towards moon base can be focused to moon base, and so that mission directorate has been renamed as the Research and Technology Mission Directorate. But I've been at Ames, as I said, for more than 20 years, really just entirely focused on technology, especially in terms of space robotics.
Thank you. Patrick.
Yeah. So Patrick Beatty, Beyond Earth Ventures. So Space Tech and Terrestrial Deep Tech Venture Fund. One of our companies just got awarded the rover contract from NASA, Lunar Outpost, and have a couple of companies that are on the lunar infrastructure side. Background, former Cal, also finance, but I'm a mathematician and also did infrared spectroscopy of comets, grew up around scientist, engineer family, so very deep tech heavy. Love to be any help to anybody in the community, startup students, et cetera. If can share any knowledge learned been a founder, scaled companies, been in tech like at Google, and then also been on the VC side, so I can maybe give some good perspective to some.
Hey everyone, I'm Alex Greenberg, co-founder and CEO of Loft Orbital. We are a 10-year-old space infrastructure company, so we integrate, launch, and operate satellites. We fly customer missions on board, and we handle the entire process from end to end to make it really simple, fast, and reliable for our customers to get missions in space. So we work with a lot of government customers in the US and all over the world, as well as other commercial space companies. This company's 10 years old. We started it in San Francisco. We now have offices in Toulouse, France, Denver, Colorado, and Abu Dhabi in the UAE. So pretty global team at this point, and don't actually know too much about the moon, but I've been in the space industry for a very long time. We operate in what I joke is boring Leo. So I'm excited to hear what other folks on the panel have to say tonight.
Hi, everyone. I'm Emerson Garnett. I'm a principal with Valerian Space Ventures. We're a space and defense-focused venture fund. Been with them now for about a year and a half. I was actually previously at Lunar Outpost, one of our portfolio companies as well. Started out in family office investing, SaaS, Bay Area. Saw the Falcon 9 land and said, that's where I want to be. Really happy with that decision. Looking forward to this.
Excellent, thanks. Yeah, there's so much money pouring into space and so much interest just in the past few months. Terry, so NASA just within the past day or two dropped $1 billion on LTV and recon drones. What capability isn't in that $1 billion? What does NASA wish they have but they don't have at the moment?
I'll tell you that that $1 billion is really literally a small, tiny, microscopic drop in the bucket of what's actually needed. I think one of the big things that people don't realize is that NASA has had ambitions to create lunar surface habitation and to really get people thinking about how do we explore the moon's sustainability in a sustained manner. 15, 20 years ago, there was a really big program at that time called Constellation, crashed and burned. And at that time, it was really founded on this idea that government was going to be the main driver behind that. It was very much a US-centric, NASA-centric, large initiative. And it didn't work out for a variety of reasons, partly having to do with budget. I think this time there's a recognition that the world has really changed. And right now, it's really, I think, an initial sort of like push by NASA. There's a reason why NASA's administrator, refers to things as ignition. That is, we will catalyze, we will ignite stuff, but we're not going to be the ones who build things. So to answer your question, pretty much everything else that's needed for sustained use of the moon has to be built. Infrastructure, I know Alex talked about that in boring Leo. Well, you need every bit of infrastructure in the moon, whether it's power, comm, mobility, surface navigation, positioning systems. All of that remains to be built. And so there's a huge opportunity for every single person in this room and beyond to help build that infrastructure. And then there's another bit of this too, that infrastructure only exists if there is a sufficient supply chain behind that. Every bit of technology that's required at the component level, at the system level, without a supply chain, you can't build it and you can't maintain it. So again, another huge opportunity.
Definitely, and building on what's missing, I watched an excellent keynote from you on the Viper project, and there you told me how NASA very cleverly was able to synthesize 4 centimeter per pixel ground data. Infrastructure, rovers, all those sorts of things need to be there. What data is missing?
Yeah, so our development for the Viper mission really relied heavily on the use of high-resolution synthetic terrain information because we needed to develop computer vision systems, and it had a lack of data at the scale that's really sufficient for us to develop and test our software system in an agile manner. So it's very clear that these days, if you talk about anybody in the software world, there's real focus on simulation and the whole sort of chain from sim to real. Clearly, more data is needed from the moon, both from orbit and on the surface as a starting point. And the things we can easily get, we're going to get. I mean, that has to do with just imagery, geometry. The things that are much harder is knowledge about the actual surface. There, you actually need to be on the surface. You need to actually do geotechnical measurements. And the only way you can do that right now is to send robots. So we need robots for geotechnical assessment.
So we heard a little bit about what NASA needs. Emerson, Patrick, you've spoken to lunar founders and operators. What do they talk about as gaps for them to successfully commercialize?
Yeah, I think it's really shots on goal, right? Having more opportunities on the lunar surface leads to more data and then allows them to design their systems in a more efficient way. So it's expensive to get to the moon. It's expensive every time you send up a rover or a lander. And so being able to maximize any of those opportunities on the lunar surface is really what founders have been talking about.
Definitely. Now, before we get to the moon, we need that infrastructure and low Earth orbit having compute happen up there, not down here. Alex, I'm curious to hear more about how we're moving compute to low Earth orbit.
Yeah, sure. So what I think has really started to happen in the last couple of years that we really see as an accelerating trend is the transformation of satellites, whether it's in low Earth orbit or other orbits, from passive platforms that just collect data and send it back down to the ground to much more intelligent, more autonomous nodes that are interconnected with other satellites and even other systems in other domains. And what we're doing is basically providing the infrastructure in space that can run AI workloads, third-party applications, anyone's software to orchestrate really complex workflows that are powered by AI. So things like not just taking a thermal image, but very rapidly spotting a wildfire in a thermal image and then sharing the coordinates, the direction, the heading, the intensity of that fire to someone on the ground who can quickly take action. That's one kind of classic example. There's a lot of others as well. So much has to happen for compute to really move to space. One is the compute has to get a lot better. So I think a lot of the vibes in space right now are pushing in that direction. NVIDIA is starting to invest in dedicated compute capabilities for space, which is super exciting, but there's a lot of companies investing in the hardware. We have to figure out the satellite interconnectivity problem, so that's certainly possible today, but certainly not a solved problem. How you move bits from very rapidly off the satellite, not using ground infrastructure, but using inter-satellite or links or data relay capability. And then the third thing is how you run AI on board. And that's actually the hardest part, and that's the problem that we're solving at Loft.
Excellent. Now, discussing what separates real surface capability versus PowerPoint capability, Terry, what do teams most underestimate about the lunar surface? Is it dust, thermal, lighting, terrain? What?
You know, everything about space is hard. We think that, oh, I can build something, I can demonstrate this, I can throw it into PowerPoint and show, hey, I've got this prototype system, whether it's a rover or a habitat. And then you do the hard bit, which is actually figuring out how do you make this work in space. And everything from thermal to radiation, just power, and the cost of these systems is enormous. And that goes kind of back to what I was saying earlier about supply chain. You know, Viper was designed as a NASA really rapid mission. It was meant to actually go from start to finish in terms of the actual build in like 36 months, which is kind of unheard of for NASA. Of course, the pandemic hit, and then we had all kinds of supply problems because we chose to purchase a bunch of things that were essentially off the shelf, like camera systems. But there are so few space camera providers that our main camera provider was 36 months late. Okay? Now, I have no idea how anybody manages a product that's 36 months late in a core part of your supply chain, but it's a real issue. I don't know. So I guess to go back to your question here, I think everything about actually making systems function in the space environment is something that people really should not underestimate. It's just really, really tough.
Alex, running a space company is, I imagine, a little bit different than your typical SaaS company. I mean, you're operating multiple satellites and now building constellations. Could you kind of tell me a little bit about what founders might underestimate the most building in space deep tech versus, a chatbot company?
Yeah. So just a bit on our company. So we have got about 320 employees across the 4 locations that I mentioned. So if you want to be global, doing complex hardware development across many different offices has its own set of challenges. I think actually the hardest thing are the product development cycle. So supply chain, for example, a lot of things just have a 12-month lead time, 6 months and months of lead time, so you often have to deal with that. So the ability to iterate rapidly is just fundamentally limited. We have software that operates our satellites. We're pushing code every single day, so that in that sense we operate very much like a traditional software company. But our hardware decisions are being made sometimes 3 or 4 years ago. So architectural decisions that we made where we really didn't know that much about what our current situation would be are kind of central to how we operate today. And actually, it so happens we're doing a whole nother re-architecture that's going to basically pave the way for the next 4, 5, or 6 years. So you really have to have a lot of prescience, and you really have to be bold in making decisions that are just going to commit you to whatever you're doing. Give you a perfect example. Our company, we do not build the satellite bus. We work with a lot of different satellite bus providers, and we build hardware and software abstractions that sit on top of the bus that allow us to really rapidly pull buses off the shelf and also fly any payload. So what buses we use is a critical decision. I have a $35 million contract with a bus provider sitting in my inbox right now, and we're deciding whether or not to sign it. And that's a very large procurement that we're going to be dealing with for many years to come. That's a huge company-shaping investment. So we're making decisions like that fairly frequently. And yeah, that's definitely not software land. I will say, though, in the current AI world, where you have to plan compute purchases and build outs and things like that, that actually starts to resemble a bit more of some of the problems that we have. I wouldn't say problems, or some of the fun challenges that we have in space.
Excellent. Patrick, you've seen pitches from founders building on the surface in an orbit. During due diligence, how do you tell a team who can actually build and ship a product versus one who just has, a nice slide deck?
Yeah, that's a good question. So I think it also depends on the stage. So super early stage, then it's kind of betting on the skill set in the background. Sometimes founders don't have the background, but they might have advisors who lend credibility that they are quality. Because that's the signal you're always trying to get. Like, a great idea is great, but if you can't execute, it's kind of just a dream, and that's nice, but that's not what we want to get stuff done. So looking at people's track record, and also, like, if depending on where they are, like early traction, like a good example, like Lunar Outpost, they had a lot of stuff that we look for in terms of contracts from the government, or the SBR, like all the way up to like a StratFi, which is a very good signal because it's very serious for the pathway. And if you've done stuff before, one thing that's going to come soon, which is going to be a nice boon to the whole deep tech side and SpaceX side of the world, is that a lot of people right now are hiring a lot of people who have SpaceX or Tesla background, because you learn how to manufacture really well and at scale, which is super important for all this stuff you do. Even some of the people I've talked to on the coordinating side, like, it's a big coordination problem getting all your things in line using AI and figuring out those things out. And if you haven't done it somewhere that's done it, you're kind of learning from scratch, and you can get to a smart place, but it takes longer unless you already know what it looks like. And with the IPO coming up, like a nuanced aspect of that is that, I'm old, so I mentored a lot of the people at SpaceX when they started, and now they're sold. They left, and they've come back, and they're leaders on Starship, et cetera. And a lot of people are not super happy with the pivot away from Mars to the moon, though very good for stuff we're talking about. So a lot of them are going to leave. And they're going to be quite wealthy, and they're not the type to buy a yacht and just cruise. They're going to build new things, or they're going to invest in new things. So there's going to be a ton of very wealthy people either doing startups or funding startups in deep tech and space, and they're going to have the chops to understand what people look like they're investing in, as well as either bringing that themselves. So we look at a lot of skill sets, and I think also there's a combination of technical and having some concept of business or partnering with someone. So many ideas work technically, but lay on the floors of many tech transfer offices of universities that never make in the real world, which I would love to see the world be a better place and have these things happen. But unlike software, where you can kind of get to business really quick, like, hey, I built an app, now I can get some customers, like a really quick cycle. All these things that we care about are B2B, so business to business, or B2G, God forbid, business to government, and those sales cycles are long. And software engineers don't always think about business first, but man, my parents are scientists, engineers, I'm a mathematician. People that think about it even less frequently than software engineers are those people, but they need to think about it way early. So kind of either helping coach or getting people partnered with that to just be aware, if you really want to make your thing succeed and be sustainable and really be in the world, you have to think about the full problem, not just the problem, part of the problem you care about that's easy, the tech stuff.
So building on the wave of new founders that will be entering the scene, CLPS has made it possible for a startup to put something on the surface for 20, 25 million, not 500 million. So I expect there's going to be a lot of small startups popping up to kind of solve these challenges. What problems do you think are going to be solved by those sorts of companies? Maybe small, single mission centric, 20, 25 million kind of investments.
Good question. So generally, I know I'm in VC. Also, I'm in VC. I always tell people to avoid VC as long as possible. It's not always a fit for everything. So there are some things that will be great companies that actually help space that aren't going to be VC backed because you need to grow fast at some point. So some things may not. But the way I usually coach founders, or even just like what we look at in investments, I'm sure very similar for Emerson, is we look for people who kind of like don't just boil the ocean. A common problem is, especially for technical, you're like, I'm going to solve the biggest problem, and like in between, nothing. And that is not okay, because you need money in between to get there. So like people that use that as stepping stones to other large things. VC needs it to be large, because most things fail, and the way the math works out, you have to have like really big things occur. So as long as that's a stepping stone to something else, if it's not a very big market itself, or the technology you're building leads to something. A good example, outside of the the space side, Commonwealth Fusion is one of the companies doing like a tokamak, really interesting company, probably most likely to get to commercial fusion. We looked at them and we liked them, and we were lucky enough to like have them want us to be like have an allocation with them. Great people. The thing that was exciting about them, instead of being like fusion or nothing, to make what they needed work, they made high temperature superconducting magnets. It's kind of vital to their process, and they need to make them themselves in the volume to make the things work. So even if the fusion reactor never works, these high temperature superconducting magnets like are used in medical imaging, et cetera. It's $1 billion business itself. So there's still something on the way. So if there are companies that are doing these things, like we see people doing like, anything infrastructure we find exciting, but you still have to figure out a large commercial process as well as terrestrial. I know probably Emerson would say for like lunar outpost, the thing that's cool, and Leo, not boring, is that they do swarms in Leo, which is swarming of satellites. And the connection to Earth businesses, which is also very helpful unless you have something already for space, is that the contested environment on Earth, let's say you're in a battle zone and you don't have access to internet, is a similar vibe of being on the moon where you don't have access to things. So their technology helps in different areas so they can monetize those along the way. So kind of being smart about how can you make your company survive to get to do the things you want to do. It can't just be a tiny thing, or if it is, how does it fit into a bigger process? Or just don't get VC money and do something cool and make it profitable itself. So,
Emerson, I'm sure you've seen many of these companies too. Curious to build on that.
Yeah, no, absolutely. I couldn't agree more. And I think it is having that clear path to revenue in case that first idea isn't in the near term. So when we're looking at companies, we want to see near-term revenue, mostly through the government. That's where a lot of these space companies are getting their near-term revenue. But then the opportunity to expand into the commercial market. I like to say, as a rising tide brings up all spaceships, as the lunar economy is being built, that's where you see these commercial opportunities. With Lunar Outpost, for example, they had Lunar Voyage 1 and then the Lunar Terrain Vehicle. The Lunar Terrain Vehicle can evolve into so many different commercial opportunities on the lunar surface, not even just scientific, but brand deals. When I was there, we brokered a deal with Juventus Football Club, making them the first sports team on the moon. So I think we're yet to see some of these different opportunities, but near-term revenue, mostly through the government, is a huge buy signal for us.
Hey, Izen, if I could answer that question. I know it wasn't addressed to me because I'm going to respond in something that's not really sort of business-oriented in terms of what I think that a lot of us at NASA really hope to see and learn from business, especially small businesses getting involved in space. And one of those things is, how can we actually engineer systems faster and cheaper that are still successful? And I say that because NASA, for a very long time, has had a very large, comprehensive, detail, risk-oriented, from a technical and programmatic standpoint, risk-oriented process for engineering space systems. I mean, you can go download the NASA System Engineering Handbook. It's an enormous document which will tell you everything that you need to do about how to approach engineering. You can go download rules such as there's the Goddard Gold rules, which specify how much margin do you need to have in your system at PDR and CDR. When do you progress from TRL 1, 2, 3, 4, 5, and up the chain? And if you don't know what those words are, there's a lot that you can learn just by looking at NASA. But what that turns into is this incredibly sort of risk-averse engineering mentality. And it's not that it's bad. I mean, NASA does this because we don't want to waste taxpayer dollars. We want to be successful. Even if we have many shots on goal, it doesn't really work for a federal agency when they say, oh, well, we took 400 shots here and like 399 were bad. Every single one of you will say, well, did you waste my money? And the answer is probably no, because we tried to take risks. but at the same time, it's far better if we say, oh yeah, we succeeded 100% of the time. And so what I'm getting at here is that it's really important to think about what can be done to reduce the cost and time and budget to actually fielding successful systems. I think if you look at companies like Lunar Outpost, for example, or Astrolab or Blue Origin, they're all trying to figure out, hey, how can I dial down like the amount of testing that's required? How can I take risks in a more calibrated way based on the supply chain, the components? Do I need redundancy? Can I fly a really cutting edge processor, or do I do what NASA does? You know, when we say, oh, we're going to be risk tolerant, it means, oh, we'll fly a RAD 750 and a RAD tolerant processor. But that's not particularly risk tolerant. That's still very much risk averse. And so I hope that all of you who are developing new systems for space think about this from engineering practice. What can you do to be faster, cheaper, you know, and really try to still be successful?
Excellent. Thank you. I'd like to talk a little bit about moving intelligence to the edge. Now, this topic is particularly interesting to me. How do we get, you know, intelligence and that sort of thing up there instead of down here? Now, Alex, Law flies this sort of AI stuff directly through virtual missions. Why does that, you know, orbit compute matter, and where is it going, both in your company and as a whole?
Yeah, great question. So for us, we always say, like, if you can do compute on the ground, you should. But the reason to bring compute to the edge and actually run workloads on board the satellite is because you need the information very quickly. So latency is the reason. Compute for the sake of compute in space, at least as of a year ago, didn't make any sense. And now it looks like some people are challenging that notion, which I'm really happy to see, and I wish them the best. But if you're doing edge compute on data to try to derive insights, you want to do that on board if you care about latency. So the wildfire example I gave before, that's a good one. There's a ton of national security use cases that we're supporting as well. You can understand why those folks need very, very low latency, very real-time reactivity. So deriving insights in real time is kind of the main reason why you would bring compute to the edge. So that's kind of a baseline. Now, what's really cool is actually how you take action on those insights. One example is just figure out where the wildfire is, send it to the ground, and hope that someone on the ground does something useful with that insight. But what we're trying to do that I really think the industry is going to go towards is satellites starting to take action themselves. So not have a human in the loop, not have a human take that insight, interpret what it means, and then retask the satellite to do something else. Have the satellite read the data, see what happened, and make a decision about what to do next, or maybe tell the next satellite coming over the horizon, hey, saw this thing, keep looking at it, or follow it in that direction. And that's really where satellites start to come alive, become much more autonomous, and you can continue to squeeze even more utility out of them. So I think that's the frontier for compute at the edge. As an industry, we're really not there yet. There's a lot of good progress towards that, but I think there's more challenges than progress at this point. But it's a huge opportunity, and I think there's a lot of potential business in that.
Excellent. Terry, so you got the same problem on the moon, but even worse, because you got a 2.6 second comm delay that makes teleop difficult. What are kind of the proposed solutions there, and how close are we to fully autonomous rovers on the moon?
So I actually agree with Alex that every bit of computing that you can get away with on Earth, you should do it on Earth. And that's partly because on Earth it's super easy, well, at least it's much, much easier to say, hey, I want to replace this compute platform with the latest thing. I mean, it doesn't take you years of qualifying and testing. You can just go out and swap the processors. And so, for a mission like Viper, we chose to do that. A lot of the data is not processed on board. We downlink information, and we just try to do this in a way that's appropriate. So if we can tolerate, for example, the latency of downlinking information, we'll process the data on the ground. I think that, of course, that's not always appropriate. It's not always sufficient. One of the big things that NASA really cares about is being able to have autonomous mobility on the surface. That is, you want to be able to drive faster and still react to terrain hazards, both geometric and non-geometric, which means you need the compute on board. Every single company that's working on surface mobility, whether it's Lunar Outpost or Astrobotic or Astrolab, they're trying to do this with faster processing on board. But now you have the problem of, okay, what processors can we use? Especially if we want those to last for a long period of time. So at the end of the day, I think it really just comes down to, not just questions of latency, but questions of, what can you actually deploy? Do you have sufficient compute power, sufficient storage? Do you have sufficient data to drive those processing things on board?
So it sounds like even though lots of data processing, the hard stuff, you downlink, but things like autonomous control and those sorts of things, we want up there. Is that correct?
Yeah, well, I mean, it goes back to, what can you get away with? I mean, if you need processing to happen quickly because you're trying to safeguard a vehicle, you can't afford to downlink it. And even if the latency is not really a problem, the question is the comm there? I mean, you have no guarantee that comm is always available. And so anytime that you really need to be sure that you can actually react based on new data or processing, then you have to localize the processing with the data.
Emerson and also Patrick, I'd like to hear from both of you. So when you're writing these checks, looking at the autonomy and the edge compute, how do you kind of price that? How do you value that? Or is it still a little too early to price autonomy initiatives?
Well, so we haven't yet done an autonomy one per se. We have a robotics company invested in. I have a YC. It's like a very dexterous hand, and that's like a input into lots of things. And then Lunar Outpost obviously has a robotics side, but the autonomy piece is not something we actively are pricing. We kind of look at the trends of like infrastructure and build and assume some of these things are happening. Like physical AI is also coming along. It's not yet here fully, but it's coming along faster. I honestly like industrialization in space, so building things is another aspect of AI that is interesting in terms of there's some companies that are working on some of the space biotech and other things for different space stations or creating semiconductor. A lot of the interesting stuff on like crystal, how they form in space is more perfect than here, so you can do a lot of cool things. So we don't specifically price it, but we do look at, and again, not to like harp on the Lunar Outpost, it's a good example. There are a lot of things that are applications of their autonomy that can be used here. They have some other rovers that can do mining work that's obviously up there to here, and other things. So we always trying to think of markets and product. I think, my background is AI, so I worked with OpenAI in the early days, and I did it back when it was machine learning, so old. But a lot of this stuff, we don't actively look to invest in AI. We look in capability and what it's going to provide as a market. So always think in terms of product and customer. I think is always good, not only for investors, but also definitely for founders. You definitely don't want to get caught up in like, I made some cool thing. It has to do something that solves a problem. So we don't explicitly price it out. I mean, it's always a nice factor if there is some kind of like platform or foundational model maybe that comes out of it. But AI is kind of fast eating itself, so like there's no real there half the time unless it's something very, very unique. So we just look at the actual capabilities that it can provide.
Yeah, I would echo that. I would say it's not something we're specifically pricing in, but I see it as a necessity, especially on the moon, where humans are expensive, astronauts are even more expensive. Their time you have to price in. So any time that an astronaut is not using the vehicle, it should be being used through autonomous driving or putting together a solar grid, putting together a reactor. And so it's not something that we specifically are pricing, but it's something that I see as a necessity for any rover or application on the lunar surface. And that comes down to LEO and then terrestrial as well.
Excellent. So moving to providing value and unlocking revenue. So Patrick, I'd like to open with you. There's a $20 billion moon base, $4.2 billion in CLPS funding, and just today or yesterday, $1 billion dropped on moon-based contracts, and SpaceX is IPOing for something like $1 trillion next month. Where does that capital actually convert into revenue for a lunar startup?
That's a good question. So I think Emerson touched on it earlier, is that a lot of this stuff in this wave that's happening, unfortunately, the world has gone from global, when I was probably some of the age of the students in the audience, to now it's going to regional and isolationism. And in that area, all deep tech is more valuable. So there's funding for it from defense or civilian side. I do stuff for the NSF, and as well as like different groups. And the ability for somebody who's thinking as an investor is that, okay, there's equity that nobody's losing. There just is like kind of like air quotes free money because they're not taking any part of it. And again, not to harp on Lunar Outpost, we love you, Lunar Outpost, as you can tell, is that they're really efficient with their capital. So like almost like 1 to every $5 or something is like what they get from, they actually take and what they get from like non-dilutive sources. So that efficiency is great because VC is a very weird beast. It needs you to grow fast. So if you have high capital expenditure, like anything cool, in my opinion, which is deep tech, you have to build something physically, made out of a factory or a technology, and VCs don't like to fund that, right? So you need someone else to take that piece. So just like you build software in a stack, there needs to be a finance stack, and now that is possible with government funding, philanthropic capital, different organizations doing different things, national labs being involved, and so it fits VC. And then on top of it, with all the technology costs coming down, like, again, old, so now people are starting to think of bioreactors in space. Back in 2001, I was part of International Space University, and Pfizer was talking to us about their own space station they want to do because they couldn't do it on the ISS, just too hard to get up there. And I was like, that's crazy. Because I know how expensive it is. Back then, if you were to take a loaf of bread up to space on the space shuttle, magic wand, turn it to gold, and bring it back, it would not have been worth it to do that. Like, it was so expensive. So, and now with the launch costs coming down, new things are possible. New business models are possible. So that means new companies can exist. And innovation unlocks. Like when I was in traditional software, we all had server rooms, because that's how you had to run your website. And they were several million each, and also very hot. And now, once you have Google Cloud comes in, that ephemeralizes that away, drops the cost, now new of innovation. So the same thing is kind of happening now with all these things at the same time. So if you care about any of this stuff, like this is the time to be involved. The wave is here, and it's not going to go away, especially with all this stuff like we just talked about SpaceX IPO and all these other things. So like I met somebody at Vast who are investor in, and she had just come out of college. Her first job was at a space station company. I was like, I would have killed to be able to have that opportunity. But now that is what's possible for anybody thinking about these things now. So like you should, and they don't just need scientists. They need marketers. They definitely need business people. So like if you have other backgrounds, you don't have to be a scientist. You don't have to be an engineer. You can get involved in these things, and we need everybody on board. So it's an exciting time, and it's going to keep going. So like, get involved if you like it.
Excellent. Emerson, again, talking about Lunar Outpost. So while you were there, what kind of milestones made customers and partners really take Lunar Outpost seriously and see it as something worth investing in or being a client of?
Yeah, absolutely. Well, when I joined, we were gearing up for Lunar Voyage 1, which was our first rover sending to the lunar South Pole. And so we survived that full mission, landing off nominally on the moon, and we had a heartbeat on the lunar surface. All of our payloads had heartbeats as well. I think also the progression from the first iteration of the LTV, which was really just wood, kind of figuring out where sensors are going to be, to the final version of it, which I'm not sure if people have seen it, but it's a beautiful American truck, showing that iterative process and that we had really the customer in mind the whole time during that design process in each subcomponent, and how it would maximize the time spent on the moon for both commercial and civil customers. I think investors saw that, and along with that, there was other lines of revenue, as we talked about before. It wasn't just Lunar Voyage 1, it wasn't just the LTV. There were follow-on missions using the knowledge we gained off of Lunar Voyage 1 to feed into new designs. But then there's also a host of other opportunities, both in the Defense Department and commercial customers. So having those multiple lines of revenue really, I think, is a buy signal for the people investing.
Definitely. Alex, so you have played this game before. Loft books revenue today. What was kind of the inflection point where customers started writing checks?
So just as context, Loft did about 105 million of revenue last year. We're still growing quite a bit. So what really changed for us was going from selling either space on a single satellite, which we were doing, called rideshare, or entire single satellites, to what are called constellations. So series of identical satellites. And you can add a 0 or 2 to constellation deals. So once those started to pick up, we signed a couple of those. Those are actually now launching. We have a number of them in space today, which is really cool. So the numbers got kind of large at that point, because you have much larger constellations that are starting to deploy, and you can start recognizing revenue. So that was the big knee in the curve for us. But to get there was very difficult, because why would anyone trust us with their constellation? They're going to spend $100, $200 million on something, why would they trust a random startup? I still don't really know, honestly. But we have a good team. We were able to convey a lot of credibility, and I think we were able to add a lot of value to customers by getting them to space quickly. So really, like, the hack for us from the early days was just figuring out how to be the fastest ride to space for any customer. And our bet was always that some percentage of customers were going to prioritize that as the most important thing. And they did, and we were able to build a business on that. Now we continue to focus on speed, but we also focus on other capabilities, reliability, things like that. And so hopefully we're going to grow the business in a number of different dimensions.
Now, we've heard from the commercial side now, Terry. From inside NASA, what's the cadence on Eclipse task orders, and what's the gap between announcement and award? What's NASA looking for there?
So NASA is looking to really ramp up the number of CLPS launches over the next few years. We had previously been somewhat happy with 1 or 2 launches per year, and we're trying to move towards a rate where it's perhaps 1 a month, which is a significant speed up for NASA. And I think that CLPS is a good example of how, at least on the civil side of space, we're looking at trying to build an ecosystem where not just paying customers like from industry or elsewhere, but also for the U.S. federal government to benefit. Obviously, the reason why NASA is doing this is because we were unsatisfied with the cost of access to space and the tremendous amount of money that every single mission that NASA had to pay to just a few of the old legacy companies. And so I think CLPS is a good example where we're trying to drive not just innovation, but reducing cost for the federal government as well. But maybe to go back a little bit to your prior question, I also wanted to throw out this other thing. For everybody here in this room here who's a founder or thinking about founding a company, I strongly recommend do not think of NASA as your main customer. That is not a viable strategy. Yes, it's exciting. Yes, NASA will certainly pay a lot of money to help build initial investment and infrastructure. I mean, the moon base to us represents an initial investment. But NASA is never going to be an anchor tenant. It's never going to be your repeat customer forever, because NASA doesn't focus on doing things over and over again. NASA is an agency focused on exploration and science. That's not to say the federal government won't invest. I mean, clearly on the defense side, we see, here terrestrially, huge repeat orders of large quantity. So if you're looking to scale your particular company, your particular enterprise, you should focus on applications like that, not focusing on civil space. So as much as I love working at NASA, don't think of us as, hey, you've got so much money, come give us some, because we won't.
Patrick and Emerson, so when you're investing in lunar startups or considering that, at each level, idea, pre-seed, seed, and so on, what are kind of the milestones that make that a viable investment, something that you would consider?
Yeah, so we mainly focus in Series A, Series B investments. At that point, the companies are a little bit more mature. What we personally look for is a product that is almost ready for commercialization. So that doesn't necessarily mean for the commercial market, could be the civil market or defense market, but that they're getting close to really releasing it publicly and feeding into any acquisition channel that they're looking for. So they're starting to bring on BD people. They're starting to start selling. And the development is there. They have their core technology. Importantly, it's protected. They're well protected. So our milestones would be having that product borderline ready and almost ready for market and go to market.
And then we do seed Series A, so just a little before. And we also have an angel syndicate that can do even earlier. And then sometimes we get pulled in, probably also like you, to later stage deals. If people like you, they, for some reason, are like, come on in. And you're like, wow, that round is as big as our fund. But luckily we have some LPs that are wealthy that they like brand names that are later stage, so we get asked to do that sometimes. But mainly seed Series A. And I agree, having done venture in the past when I was at the later stage, it's a different mindset what you're looking for. So we're looking for, they haven't grown yet, but they have to have traction. So again, it's like, it can, and I totally agree. I love NASA, but it's like not your final customer. If it is, then that's like not a business really per se. COTS also prior to CLPS was a great example of jump starting things, also with somebody who's already wealthy to then fund rocket development. But that is not a that's a hope, not a super strategy to like build on. But it is a great jumpstart and platform, another signal for investors. So it's really good for investors to see that, like for Lunar Outpost, they just got awarded the 220 million, which we did not factor in them definitely getting. I know when we all those projections we say is nice to have, but we don't know if that's going to be real because they're competing against other people. But that's great. That's like extra for us. We're like, wow, they're going to really take off. But we tend to look at, again, like team, quality, have they done it before? I think there's also the myth, at least in software, of like a couple people in a garage, never done this before. No, that is totally not true. Like people who have done any startup of any kind ever, there's so much you learn and realize you didn't know what the hell you're doing the whole time, the first time around, that automatically makes you better the next time. So we look at people who have some track record, ideally, of exits in that area. They have a team that has quality and actually knows what they're doing. We're a very technical group, so we do the science due diligence also. So we actually like dig in pretty hard. And if they're kind of hand wavy or don't know what they're doing, that's a bad sign. But there are other signals, like do they have good advisors? Do they already have some traction? Again, this fund we have is still like an early fund, so we don't lead around, and that's just like somebody setting the terms, for the investment. So we also look to see who the lead is, and if there are other investors are also like to hurt a little bit. So if you're like, oh, we see Emerson, he's super cool, he is on that deal. Oh, that's probably a good deal. Then we should get involved. But if they don't see like someone like an Emerson, you might be like, you have some kind of sus investors or we've never heard of. They're like, why have not good investors come with you? It's a kind of chicken egg problem because you're like, I'm looking for investors, having been on the other side. So those are some like kind of traction, like some traction has to be there. I think also to your point on the government side, whether it's defense or otherwise, there's a lot of nuance to that pathway. So like NASA and others as defense also use SBIR, which is small business grants. And they can also be for universities. And I've sadly known most investors who don't know, but definitely startups don't know the pathway, how it works, what it means. Like there's phase 1, phase 2, and then depending what area you're in, there can be on program of record or the StratFi, TACFi from the military side. And those are very different beasts. And if phase 1 is like could be like $70,000 and like anybody can almost get that and you never get another one again. That's not exciting. That's not really a business. But if you get further down the pipeline, then you become more enmeshed in the ecosystem, right? Like even for NASA, where they like start to know you and they're like, oh, we trust these people. We're going to have them on board. So those are proof points too that we look at. I think those are some of the main ones.
I would add, as you said, the team. Looking at a team that understands scaling, not investing in 10-year-long science projects, but things that are commercially ready. Oftentimes that's coming out of SpaceX or a similar company that they want to get to scale quickly and they want to start selling.
I just want to add on that great point. So just to be clear, academic background, love academia, but academia, a lot of things either in biotechnology or other places is like, ooh, it works in the lab. I'm like, awesome, that is not at scale. And they're like, oh, well, definitely at scale. I'm like, this hand wave thing is not work. Like you have to have thought through those things. So that's why the scaling part of people who've done it in industry is important. So if you had like nothing but people who are only academics who are vouching for you, then I'd be like, I do not trust that you're going to scale. So you can have a couple that might have the like fundamental science, but you have to have people who've done it or have done it in industry. I don't care where it is that shows you can scale, because the whole point is the scaling for VC. So if you can't grow big, then it doesn't really fit. Nothing against your thing. VC is not really for everything. Most people try and wedge it in, but it has to grow fast. And if you don't have a team that can do it and grow fast, then it's like not really a fit.
Excellent. I'd like to end on a little bit more of a fun question. Alex, I think we already know the answer to this one. But for each of you, if somebody wrote you a check tomorrow and said, go start a MoonTech or a space tech company, what problem would you be solving? What would you be building?
Honestly, I'm so beaten up after the last 10 years, there's no effing way I'm doing another space company.
I mean, I do think that's kind of a funny question, actually, to your point, because I feel like people that ask that, I'm like, you clearly have never done a startup. They're like, oh, just go do a startup. I'm like, if you have done it, you realize like eating glass, staring in the void, it's likely to fail, almost certainly, and it's like a lot of work, so you really have to believe in it, and it's not just something you do. I don't know, I like a lot of like things beyond even the venture side, so like there's stuff I might even do that is like, if I had a lot of money, I'd just do some nonprofit, like deep research on Science Institute type stuff. or even not even in a company, honestly, at this point. Because there are a lot of brilliant minds out there that are now shifting away from optimizing ad clicks in software to doing more of this stuff, which, you know, I'm already just excited that if I can help anybody do that, I'm excited because you're making the world a better place. I don't necessarily need to have to do it myself, so.
Boy, that's a really tough question. So assuming that I had infinite resources and hopefully finite time, because I don't expect to live forever, I think what I'd most like to do is find a way, and it doesn't necessarily mean technology. It could actually just have to do with like process or, you know, something fundamental about the way that we structure just everything associated with this, to make it possible for every single person in this room to get to the moon for the cost of an airplane ticket. Okay? I have no idea what that means. It could mean new technology. It could mean just changing what it means to actually be profitable to get things to space and sustained in space. But if we could do that, you know, before I die, hey, let's do it.
I think I'd probably do lunar agriculture. I think it's a little out there, but we've talked about in situ resource utilization on the refueling side, but being able to set up any type of fuel source for humans, making their life as easy as possible on the moon. It doesn't need to be this harsh kind of environment, giving them the creature comforts.
Excellent. Now, if there's one thing you wanted to leave with the audience, for each of you, maybe an offer, maybe an ask, something of that nature, we'll go down and cover that.
I guess my ask to all of you is think of new technology that will change the way that we live and work in space, and come talk to one of us right afterwards.
I think I was talking to Matt earlier about this. So like, in case it's not obvious, if we're here, we actually want to help. So like, if you would like to talk to us, please reach out. We might be busy. Doesn't mean we won't want to talk. You just nudge us again. So I think the Berkeley community is special. Like I think everybody's here because they like this community, this like area. I like to give back. So please don't worry. Like I can't talk to any. We're just all people. So if we can help, please do. And please, if you are thinking about like, oh, I want to do this. Especially a lot of young people will be like, oh, they hear these things, I need to do this, 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 and get this certain job that's everybody's telling me to do. Do what you find interesting. I was very lucky with my parents telling me that, and they didn't care what I did, and I ended up in this weird area. But this is like the time to do this kind of stuff, so this is not even that risky anymore. But if you like this stuff, it really makes the world a better place, super mission-oriented, whether it's space or anything else in deep tech. So I would say please try. And worst case, if it doesn't work out, you've learned a bunch and you do something cool the next time. It's not going to set you back in any way. If anything, make you a more interesting person. So
I see a lot of young people here, so I'll give my commencement address in 30 seconds. I'm a big believer in that you make your own luck. And I think the way you do that is by working your ass off in your 20s. You can just get so much leverage by getting, you mentioned shots on goal earlier, shots on goal reps. You will create crazy opportunities for yourself just by working your ass off in your 20s when you have a lot of time, no one else that you really have to worry about, and doesn't require much money to keep you alive. So work your ass off.
Yeah, I think it's just reiterating what you both said. Now's the perfect time. Space is at an inflection point. If you're here, you obviously love space. Now's the time to start your own thing or go work for one of the companies doing commercial space stations or lunar rovers, whatever you find interesting in the sector. And absolutely, please don't hesitate to reach out. If you have a passion about space, space investing, space technology, please come see me after, shoot me an email, connect on LinkedIn.
Well, thank you. I think we've had an amazing discussion and provided a lot of value to everyone in the room and to ourselves having this discussion. So I would like to give a round of applause to our panelists. Definitely take the time during networking to chat with these panelists. If you have questions, make sure to drop them into the chat or reach out to me on LinkedIn or something. I'm very easy to find and reach there. And yeah, thank you. Thank you. Now round of applause. If you can hit that slide real quick. Now, before we dismiss for networking, I'd like to share an opportunity for all of you. If you got value out of tonight, we're planning a all-day MoonTech Summit on August 20th, planning on having that on campus with way more speakers than we have today, similar sort of topics, talking about lunar commercialization. This is, to my knowledge, the only one in the US talking about commercial moon stuff. Scan here. This will bring you to a Google form. This is our early bird ticket, so earlier than early, for the best deal when we send that out. It'll be free to attend, and we'll have a dinner reception for networking that'll be just a little bit to cover dinner. Other than that, let's get to networking, and I hope you all have a great evening. Thank you, everyone who came out to the live stream. This is Izen. Make sure to drop your questions in the chat, and I'll make sure you get a response. And then if you aren't able to scan that QR code, just reach out to me on LinkedIn. I'm the only Izen, I-Z-E-N, on there. And I'll be happy to answer any questions and get you in there with that early bird.